Okay, we'll go ahead and do this one. This one will be a pretty quick one. I don't know how well you'll see the board. I'm going to show just a video clip quick. There are 4 fundamental forces, and there's argument about that. I'm not going to go into that. That's a physics class. But in this class, we have gravity. We don't really care about gravity in chemistry. It's not a force that really has a lot to do with what we do. But just know that gravity, it's all math-based. All of them are. Gravity has an exponent of something times 10 to the negative 11th. It's F equals g m1 m2 over r squared, and the g is to the negative 11th. Pretty weak. Gravity is really weak. We can overcome that with a magnet, and that's what gets us to the next one, an electromagnetic force. When we use a magnet to pick up a paper clip, we've beat gravity. We've used the electromagnetic force to do that. The electromagnetic force is times 10 to the 9th. So it's 20 zeros stronger than the gravitational force. And it's much more important to us. It's what keeps things bonded together. So in chemistry, we care a ton about the electromagnetic force because that's where we get chemical reactions. Okay? In chemistry, we move electrons. That's a chemical reaction, sorry, and we're messing with this force. And we can get some energy, some pretty energetic things. We get a lot of heat and a lot of reactions. Okay, next we have the weak force, which we're not going to really talk about in this class. I don't remember that exponent. It might be 24. It's pretty strong. It's called weak, though, because it's weaker than the strong force. The weak force allows nuclear things to decay over time. All right, then the strong force. The strong force is what's responsible for keeping the nucleus together. Because protons don't want to hang out with each other. They're both positive. They would fly apart, so you need something much stronger than the electromagnetic force. And that's where we get this strong force, which has an exponent to the 28. And I had to look that up. I'm not positive if that's exactly it. But it's a really big number, way bigger than the rest of them. All right? So the strong force is where we end up getting our nuclear reactions, like a nuclear bomb. And it's important for you to know the following. In a chemical reaction, we get some energy out, but almost no energy when we compare it to the amount of energy that we get out of a nuclear reaction. So I'm just going to show a quick video clip of 2. That was probably really loud. Okay, so here on the screen, that was kind of dumb to film it that way. But here is a nuclear bomb being ignited, and you may or may not be able to see. It's a huge amount of energy. We have our nuclear cloud that just goes up in a big fireball. That's a nuclear reaction. It's very, very energetic. Now, we'll show you a chemical reaction. So this is just a, sorry, that was probably very loud. This is a video I recorded at a campfire, or a camp out we had of just a campfire in slow motion. You will notice much less energy is involved in the campfire. In a campfire, we're breaking the chemical or electromagnetic force. In a nuclear reaction, we're messing with the strong force, or the nucleus, the force that holds it together, so the amount of energy exchanged is massive. So your core test, remember, 100% remember, nuclear reactions are extremely more energetic than chemical reactions.